Today, I'm gonna show you how to go from this to this in less than 7 minutes using Biopython and the NCBI. Maybe Wikipedia is still your best friend, or maybe you have decided to move to the new technologies. Anyhow, there's a lot of ways we can find a list of interesting species we can use for studies. Charts are nice, but we gotta start programming. I'm gonna use JupyterLab because I find it comfortable and useful, but you can use wherever it suits you best. Now that we are in JupyterLab, we can create our first notebook. Here, we will be able to start working with our code. First, we will import from Biopython the following functions. This one is going to allow us to work with NCBI, and this one, sec.io, is going to allow us to work with sequences. Then we will define our function. In this case, I'm going to call it upload cytochrome B sequences, and the argument is going to be a species list. Then we have to enter an email so that NCBI can contact us in case there's something wrong. Your email example.com. To make things faster and easier to understand, I'm just going to keep copying the code and I'm going to explain it to you. First, we will iterate in every species that we have in our species list. We will establish a search term, which is going to be our species and the gene we're looking for. Also, we will indicate that we want it to be less than 2000 base pairs of length. This is so that we don't get whole chromosomes that's gonna slow our algorithm and that we don't really want. Now we will actually perform our search. We will define the database we're using. In this case is nucleotide. We could be looking for gene, protein, the term we're looking for that we defined previously, and the maximum number of hits. We're gonna store these records by reading our handle, and then we're gonna close the handle. Next, we will create another conditional so that if there's nothing in our record, we'll print that we didn't find any sequences, else we're gonna start the important part of our function. We're gonna get all the ID list in our record object and we're gonna store them in sec.ids. Then we're gonna fetch from NCBI these sec.ids in the nucleate database in FASTA format. Using sec.io, we're gonna parse through this handle and we're gonna extract the sequences, storing them as a list in our variable sequence list. We're gonna create an output file which will have the name of our species, the name of the gene, .fasta, and we're gonna write, again using sec.io, the sequence list in the output file in FASTA format. We're gonna close our handle and we're gonna take the number of sequences and we're gonna download. We're gonna print that we downloaded the number of sequences of the cytochrome B for our species. Now, all we have to do is execute our function. I said in the beginning that we were gonna use species list and we're gonna iterate through it. Well, the species list is gonna be in a text file, as we said, which is gonna be, this is our file path. So we will strip every line in our path, which is every name of a species, and we're going to create our species list. Now it's time to execute the function using the list. It's going to take some time, but it will slowly download all the sequences we want. It will say one sequence of this gene for this shark. For this one, 2. This, no sequences were found, no sequences were found, no sequences were found. And it's going to be creating our files. We can see here, complete CDS. Here we can see 2, the complete CDS, and another one. And it will keep working until it has the 100 sequences. We have all our files here. We can investigate them if we want. We can see we have 2 cytochrome B genes in this example. Here we just have one. But what's interesting now is to actually merge all of this in a single file. We're gonna create our file, we're gonna get the working directory, which is this folder, and we're gonna iterate through all these files in this file path, as we said before, and we're gonna check if they are FASTA files. We're gonna get the list of sequences in this file, and we're gonna select the one we want. In my case, I want this one, if possible, containing mitochondrial cytochrome B gene, the complete CDS. If it's this one, it's gonna append it, and if it's not this one, it's just gonna take the first sequence in the file. We're gonna write this in our output file using again the sec.io function, and finally we're gonna get a print statement that's gonna tell us the number of sequences we've recovered and the sequence length of them. We execute, and it says we merged 10 sequences of this length. So we can see the lengths are pretty close, which is gonna be perfect for our future alignment. And here we can see our file. If you want more content, fast and to the point, consider subscribing. Thank you.